Hello all, a very warm welcome. Today we are looking at a LeetCode question 4 in January week 2021. The question says merge two sorted lists, and herein what we are going to do is we have to merge two sorted linked list and return it in a sorted list. So that means we have to create a third linked list which is going to store values in a sorted manner from these two linked lists, and this list should be made by slicing together nodes of the first two lists. Yes. So we are given two input linked lists which are sorted in manner, and then we are going to create a third linked list out of it which is again going to be in a sorted manner. However, it will be merged. Uh, it will be merged of the first two input linked list. Now, before going further, let's try to just quickly run through what is a linked list. Linked list contains a set of nodes wherein each node contains a value reference pair, wherein my reference contains a value contains the value which whatever the integer value we're going to store to it, or the value we're going to store to it, and it contains the second part of it contains the address to the location of the next node. So this way all the nodes are associated to each other because one node contains the address to the next node. So if we come back to the question, herein 1 contains the address location of the node 2, and hence it is referencing to the node 2, and 2 is referencing to node 4. So what we are going to do is we are going to tweak these references such that we are going to have the value in the sorted manner. What do I mean by that is 1 is going to reference say 1 now, and then the next one will now has to refer to the next smallest value which is 2, and then 2 has to refer to the next smallest value which is 3 out of the remaining lot, and similarly going forward. So how we are going to approach this problem is we are going to create, as the problem statement said, we are going to create one output linked list, and we'll just assign a dummy value to it, and then considering each linked list contains a head node, we are going to just assign that output linked list to it. So now I have a head node of my new list. Now what we are going to do is we are going to iterate through both the linked lists until unless any of those are null, as in they are not referencing to the any of the next nodes. So now considering we are going to do in the sorted manner, so we are going to compare the value of each of the nodes. So here in my L2 node value is smaller. So what my linked list will contain is L2 because that's the smaller one. Else, that means either the values are same or L1 is smaller. I'll set it to the I'll set output node dot next to L1. Now one thing which we need to notice, considering we have already utilized this L2 node, we have to move to the next node. So what we are going to do is L2 will now move to L2 dot next. So, and similarly for L1 will move to L1 dot next. What do I mean by that is I have my output list which is say output list which we created, say this is one. Now when I compared L1 and L2, say first node of both of them, my L1 and L2 are same. Now in this case with the code which you're going to have, my L1 node will be assigned to my output list. That means this node gets assigned to this one. Now what I have next is I don't have to look at this node anymore because this has already been utilized and is part of my new node. Hence we are going to move to the next node. So my L1 will now point to node 2 which is here, and it will be compared against node 1 of L2. Hence we are moving to the next node. Once I'm done with all the operations, what we are going to do is, considering I have already assigned a value to my current output linked list, I'll move that to also a next node. Nice. Once, say now, there might be scenarios wherein my L1 and L2 length are not same. In that case, my L1 may terminate before L2 or vice versa. So to take care of those boundary scenarios, what we are going to do is we are just going to have a simple check that if my L1 is not equal to null, then my output linked list dot next is equal to L1. Similarly, output linked list dot next is equal to L2 and return head dot next. Why head dot next? Because we gave it value -1 as a default value. What we are going to return is the first node, whether it is L1 or L2. So hence we are going to do head dot next because that will be my head. Let's see if that works. Cannot implicitly convert type list node to bool. So L1, this is at line number 31. Okay, I didn't do much. I just removed the space in between. Let's try to submit it. It got accepted. So this is it, guys. The complexity, let's talk about time complexity. Time complexity will be of O of n, wherein my n will be equal to number of nodes in L1 and L2. So that will be the time complexity of this, which is O of n. Thank you, guys. Thanks a lot for watching the video.